Welcome to the HiRSE-Seminar series on research software engineering in Helmholtz and beyond.
All right. Well, thank you very much for the invitation to speak here. This talk is based on work which came out of a poster which I was able to present at the RSE this year. So a lot of it is based on ideas that have come forward from the discussions that I had around that poster and the engagement from the German RSE community. So thank you very much for being part of this research. So this talk is based around the work which is now a preprint for the ECEASST journal, the post proceedings of that RSC conference. So there's a link to the preprint if you'd like to know more or have even more detail than this talk will provide you. And I'd also like to thank my collaborators, Dr. Julian Sint and Professor Neil Chu Hong. They've both helped steer this in the right direction. So I hope you enjoy what I'm able to present of my research so far. So RSC personas are essentially patterns of collaborative research software repository interactions, specifically in the case of my research from GitHub. And this is a concept that I've developed over the last couple of years in my PhD research. I think it's important to have something like RSE personas because, as a taxonomist with a background in naming things, I think it's really important to understand that if we can name something, it makes it easier to think about and talk about, and much easier to kind of instigate change or develop training around that thing. So that's kind of the underlying motivation for my research is essentially I want to come up with these ideas which can help describe common or rare patterns of behavior when people are developing research software engineering kind of practices or research software itself so that we can kind of work with these personas to say, oh, hey, maybe we can identify some training needs for this group, or we can recognize that these groups need much more recognition of their contributions. So moving on, the objectives of my research have kind of come around uh, from this idea into sort of an empirical study. I've used software repository mining to gather data from GitHub, and I've selected my repositories from a research software repository or research repository, Zenodo, to try and make sure that as many of the repositories were probably likely to be research software as I could, to try and figure out my sample. And there's a little more detail on that in the workflow image here. But really, after running a small pilot study with around 800 individuals and across maybe around 40 or so repositories, I'd found that there were two sort of clusters of groupings of behavior, and they were really quite vague. There was high and low, so not too much resolution there. Um, but I had kind of hoped to look at applying further clustering and try and get more resolution on those personas, particularly the low resolution group, which was really quite vague. And I also had an idea that there's something to do with the amount of responsibility that's associated with particular types of interactions. So, for example, pull request closure is something that not everyone in their repository is likely to do or have the permissions to be able to do. And assignment to issues, perhaps that's more of a sort of project management element to it. So I expected these types of responsibility interactions to influence the creation of personas particularly. And throughout the slides I'll present in a minute, the data set that I've been working here with is over 100,000 repository individuals. And just a note on that term, repository individuals, because I kind of expect that the same person can wear different hats on different project roles. You might have different patterns of behavior in different repositories that you contribute to. So essentially, I've taken the GitHub username of each individual, and I've combined it with their repository name that they're contributing to, and I've treated that as the unit of study, so that I'm not necessarily combining different projects worth of behavior for the same GitHub username. And overall, like larger research included over 1,000 repositories from GitHub. So in my pilot study, I was trying to explore where and how I might find these personas. Um, and I came up with this sort of quadrant idea where there are axes which represent sort of high and low contribution of some kind. So along the x-axis is UIT here. This was from my poster, the original kind of idea that I had come up with. I was kind of expecting to find four rough types of personas. And my pilot study really only proved two conclusively. We had active leaders who are in the top right quadrant, and they demonstrate quite a wide variety of interaction types in their repositories. So UIT is unique interaction types. And they also demonstrate high MRC. So that is mean repository contribution. So for all of the interactions uh, that they make, what is the percentage of their repositories interactions that they are specifically contributing to? So that represents the volume of interactions. And as I say, really from the pilot study, I was only able to really strongly say that there were these two clusters. So thinking about the data that I had gathered from my MSR, my software repository mining workflow, I was looking at six interaction types specifically. There are more that I hope to add kind of as I develop this research, but for this work, I focused only on six. And those are commit creation, issue closure, the number of issues that someone is assigned to, the pull request creation, and how many pull requests they close. These I was able to kind of combine into this MRC, this mean repository contribution, which kind of averages the percentage of all of those. And I looked a little bit at how many days people interacted for and things like this. I also looked at kind of the net of their created and closed issues and pull requests, just to kind of get an idea of what was each individual's overall impact to their repository, what was their contribution. Um, so these were kind of the initial clustering variables, and then I worked to recluster these for the better resolution that I was really hoping for. And so this is the result of that first step of clustering, the initial clustering. So I use the Kalinske-Harbaz index, which is a way of evaluating how many clusters you need to kind of train for without overfitting. And so three turned out to be the best number based on the data that I had. And you can kind of see here, we have these three groups. High interactivity, low interactivity, and moderate interactivity is kind of what I'll show you they represent. But for now, you can kind of see the different colors. And if you're not familiar with a dendrogram, this type of plot, the longer vertical heights from the kind of horizontal bar basically represents the distance between the members at the bottom of that branch in terms of their data compared to everyone kind of on the other alternative branch. And longer distances mean greater difference. So in this case, we can see that the high interactivity group is really quite different from the other two groups, the low and moderate interactivity groups. But actually, they're reasonably similar. There's some difference here, and that's something that we kind of wanted to get more information about from the next step of clustering. But essentially, the numbers along the bottom, it's quite difficult to read, I understand. But these essentially refer to the numbers of repository individuals who kind of ended up at the bottom of each of these little branches. And by and large, we can think about these as our three interactivity groupings. So because my data was quite multi-dimensional, I wanted to try and visualize that in a slightly different way to really look at what the overlap and what the spread might be of these potential clusters. And so I used principal component analysis for that, which essentially tries to reevaluate the data and describe it using eigenvectors. And these eigenvectors are represented as the different axes on this graph here. And we can see from the kind of rough sort of splatter of dots here that the x-axis kind of describes the most difference between these clusters. We have the low and moderate group kind of crushed over here on the right-hand side of this plot. And then the high interactivity group are sort of much more spread out and much further over to the left. And this is definitely sort of shown by the amount of variance explained by that axis, which is around 80% of the variance between these clusters and the data points within them. The other two axes explain a little bit less, but they're still important. And what do these axes mean? Using feature importance analysis, we kind of ascertain which of the variables is most responsible for that difference on these eigenvectors. And so the x-axis essentially represents, in large part, the amount of pull requests closed. The RC stands for repository contribution. So this is how many pull requests an individual has closed on behalf of their repository. And the Y and Z axes show the number of commits created and the number of issues closed. So interesting, we're kind of seeing the closure, especially a pull request, that high responsibility interaction type that I talked about, as being quite important in splitting those different groupings. So, just to kind of summarize, we, from our initial clustering, came up with these three levels, these three main groupings of interactivity, which generally speaking describe the variety and the volume of interactions. So, just kind of a quick delve into that before we split that initial clustering further apart. Um, we can see that the low interactivity grouping that I'm calling, we have far narrower, far lower breadth or unique interaction types. So that this is essentially a very low variety of interaction types. So they might be, for example, only contributing a few commits or just commits only, or perhaps only opening an issue ticket. Whereas for the other two groupings, we can see that the number is much closer to the six, which is our all of the included interaction types that we studied, which means that the variety of interaction types that these repo individuals are contributing is much wider. But the y-axes here are not the same scale, and we can see that there's far more of our sample falls into the low interactivity grouping than in our high and moderate groups. And thinking instead, we've moved on from variety. We now think about the volume, and these the plot here essentially shows the MRC, which was the mean repository contributions. And we can see that one of our groupings has a very high percentage of mean repository contributions, and the other two are moderate and low. And essentially, these two elements were kind of why I've referred to these as the high, moderate, and low interactivity groupings. Um, but essentially, we don't have much more detail here than we really had at the beginning in the pilot study. So this is where we take a leaf out of the persona creation guidebook, and we recluster these individual initial clusters separately. So this means that we avoid kind of losing some of the really interesting but infrequent signals from our data amongst the kind of most common ways that people interact with repositories. So if we once we've reclustered with those same variables, but using only the subset of each of those initial clusters at a time, we come up with uh, these seven distinguishable groupings, which we have used as the foundation for our RSE personas. So in low, we have ephemeral contributors and occasional contributors. In moderate, we have project organizers and moderate contributors. And in the high group, we have three personas: low process closer, low coding closer, and active contributor. So, what's going on here and what do these look like? So, let's look into it a little bit more. So, I won't kind of go into the nitty gritty of this slide particularly, but essentially, when you look at the interaction types that are contributed and the amounts of those across each of these subclusters, which became our personas, you can see that there are quite a lot of differences. We can see this kind of low, moderate, and high pattern generally, but within that, we can see that there are some people who contribute far more, and there are people who contribute a little less. Um, and so let's try and pull that apart to really explore what our personas mean. So we'll start with the low interactivity personas because these make up the lion's share of our data set, essentially. Um, we saw that cluster two, which was the low interactivity cluster, is 97% of our data set. So it is quite a lot of folk. So chances are, statistically, you're probably going to be one of these. Um, but there's two options for you if you do fall into this lower interactivity grouping. So let's explore those. What splits those two groupings apart? Well, in this case, they can kind of more or less be described by looking at the number of unique interaction types and the MRC, that mean repository contribution, that volume of interactions. So, if we take the ephemeral contributors first, we can see that those have a very low mean UIT. So essentially, they're mostly contributing to just one type of interaction when we have looked through that data. Whereas their sort of sister persona, the occasional contributors, they're kind of closer to the mid range. There's a little bit more variety going on there. So they might be contributing to perhaps some commit creations, opening an issue ticket, maybe closing one or two. Um, and then when we look at the volume, then we can see that kind of same pattern. The ephemeral contributors are right down at the bottom, very low volume of contributions overall, and a little bit higher in terms of the occasional contributors. So if you really love a bit of detail, here's a little bit more for you. So the ephemeral contributors made up over 91% of our entire data set of over 100,000 repo individuals. And so that suggests that the majority of people have this very narrow and shallow contribution pattern. Um, I'll just explain the name ephemeral contributor. Ephemeral is a word that I really love the sound of. It means short lived. And these guys are only here for a very brief time. So when we looked at the number of mean days upon which they contributed an interaction of any type, the average was 3 days, which is really, really short. Essentially, they're just here for the blink of an eye. And we can see from the kind of low net impact and the low mean repository contribution numbers that they're not essentially doing too much work once they're there. So they might come to request a fix or perhaps a new feature for that repository. Um, we see higher number of issue creation than either commits or closures. So that suggests that they're opening tickets perhaps to say, "Ooh, I've noticed a bug. Can someone fix it?" Rather than saying, "I've noticed a bug and I fixed it. Here's the results." But what we do see with these is plenty of contributions of ideas or potential fixes that need to be addressed. So we have a really large percentage of these. And although they're not necessarily doing too much work individually, en masse, that contribution is really, really valuable to a research software project because the more eyes on your code, on your project, the better. And so this brings us lots of possible ideas. Um, Comparatively, the occasional contributor, they have kind of low contributions generally and sort of a moderate variety, as we saw in those plots. They're slightly higher frequency, but they're still pretty rare. But again, that volume being 5% of our data set, more or less, still means that there's a lot of them out there and they're in general contributing a lot kind of as a group. So we shouldn't write those out just because we kind of see them as low interactivity. Moving on to the moderate interactivity personas, we have two options there. So we have our project organizers and moderate contributors. So the key splits between these two seem to be particularly focused on closure of pull requests and closure of issues potentially. So if we look at the pull requests, our project organizer has a far lower percentage that they're responsible for, whereas the moderate contributors are comparatively higher. And the this net kind of created closed issues is essentially the number of issues that a repo individual is responsible for generating, creating, and then also subtracted for that is the number that they've closed. So if you have a positive value for this, you're creating more, you're opening more issues than you're closing. And if you have a negative, then you're closing more than you're opening. So it's this kind of overall net effect. And we see that they're both negative, so they have a sort of general overall closure. But this is much stronger in the moderate contributors than the project organizers. And so if we explore the characteristics of this group a little bit more, we can see that the project organizers are kind of this wide but shallow engagement. We've got this high variety and slightly lower contribution volume compared with our moderate contributors who are varied and sort of moderately deep in terms of the volume of contributions. Um, but the real difference is in terms of how they do the things they do, or what types of things they do. We can see that the project organizers have, we've got that low closure rate, but we also have a very low rate of commit creation. But at the same time, they're quite strong at being assigned to issue tickets. And we thought about why this was, and I suspect that this is potentially the kind of issue ticket assignment that happens when you're keeping a member of your team in touch or in the loop about an ongoing item of work. You know that they might not have the time or potentially, be involved with that type of development. But you want them to be aware of it. So this might be perhaps more of a project manager role. And so when we kind of thought about that space on our kind of hypothesized quadrant of personas, this sort of matches the project manager role that I had kind of initially expected to be in the dataset, but didn't find in the pilot study. Um, so these guys are potentially focusing on managing projects and development effort instead of really kind of getting hands-on with the code and taking an active development role. Um, and for the purposes of avoiding overlap with official project manager roles, I've renamed this persona to project organizer just to kind of represent that this is based in the kind of repository contribution data, and it's not necessarily the strict project manager definition. Meanwhile, our moderate contributors, they are sort of involved in using those development management features, such as issue tickets or pull requests or assignment to kind of manage the development. But they also have a much higher rate of commit creation. They're at 30%. So it's much higher than their sister persona of 10% here. And finally, we kind of move on to these high interactivity personas. And we have these three options. Uh, so let's take a little bit more of a look into what separates these. So when thinking about how to split these three personas, what we identified were these sort of two main elements. Um, the issue assignment is really good at separating off our low process closers. So if we think about how many issues were assigned within the repository, the low process closers were we're not assigned to many of those at all. While their sister personas of low coding closer and active contributor were much more highly assigned, very, very frequently assigned in the case of the active contributors who have the highest values, kind of up around sort of 85% for the median there. Um, and on the alternative plot here, we can see commit creation. And down at the bottom left here, we can see the odd one out this time is the low coding closer. Um, and they have a far lower rate of commit creation on behalf of their repositories than the active contributors and low process closers. So when I say process in the name of the low process closer, I'm talking about perhaps more management features such as opening issue tickets or assigning or managing the effort. Whereas with low coding, the clues in the name, these guys are much lower contributors of commits overall than the alternative personas. So what we can see between these two is really interesting. This kind of divergence of behavior that all three of these personas are highly interactive. So they're contributing a lot in terms of volume and variety, but that is not necessarily uniform amongst these three. Um, what we see in the low process closers is a strong preference away from the assignment and issue creation in favor of pull request closure. So this is why they're closers, because they have massive rates of pull request closure for their repositories. Almost 85% of any pull requests that get closed in the repositories of these guys, it's from them. And so this gives them a really strong net closure rate because they're not really opening much and they're closing loads. So it's very, very strong. And we see this with issue tickets as well. Um, so we can kind of characterize these potentially as people who might be a fixer sort of role in their repositories. They love to close existing tickets and pull requests much more than they love opening them. So they're just getting things done. This is why we're kind of thinking about them as low process because they're just like, let's get it done. Let's write the code. Let's close that. Job done. Whereas our low coding closers are a little bit different. Um, we're seeing still very high levels of closure of issue tickets and pull requests, similar to the low process closers. But the difference here is that the rate of commits is comparatively really low. So they're closing all of these items without necessarily having the same volume of commits that we would expect for that rate of closure based on the other two personas. And thinking a little bit about why this is, they might be closing and triaging duplicated items or irrelevant sort of issues or sort of old items that don't necessarily have a big requirement for commit creation to resolve them. So it's much more this triaging and management of development effort rather than kind of getting their hands dirty and getting into the code base and contributing a lot to that. So it's quite a different style of behavior. And finally, our active contributors here. They're another one of these really rare high interactivity personas. These guys only represented 0.2% of our entire rather large data set, so really quite rare. Um, and these show kind of thinking about our sort of high variety, high volume axes. These are right in the top right corner, very high variety and very deep volume of contributions overall in terms of interactions. And they also show the highest issue ticket assignment. So that's about 77%. And when we think about why that is, well, we can kind of see their net closure is very good. These guys are going to get it done. So we have a very strong closing uh, sort of value, and that works out quite well on net. But at the same time, kind of thinking back to our table earlier, they still have a very high rate of commits. So what we have here is a high usage of these more development management features, such as the issue tickets, the pull requests, and the assignment, but also the impressive code base contributions to back that up with their commits. So really, these are kind of important core members of their repositories who are really driving that progress within their repositories. And kind of rather happily for me, that kind of matches very well the active kind of contributor or active leader that I had kind of hoped might be in the hypothesized personas. Um, so we've kind of seen what describes these seven personas, and we've seen the differences in the patterns of how people interact and what kind of separates their GitHub interaction data. Um, but obviously, this is a research study, so I have to kind of put that in context and suggest areas where we could do more or we can potentially improve this research. And one of the elements that I think is worth spending some time on is the variable selection. So, for talking about these personas, I've been using UIT, so that unique interaction types variable to describe the variety, and that's a number. That's the number of unique types that someone has contributed. But what that doesn't tell us is the combinations that we would get when that is greater than one, which is, let's face it, the more interesting kind of case. Um, so there's probably quite a world of difference in our data set between the contributions of someone who is creating some commits and opening an issue ticket compared to someone who is, you know, creating some commits and closing a pull request. That's quite different behavior. Um, but we can't really look at that in too much detail in the way that I've analyzed the data this way. And we can look at MRC as a summary of kind of the overall patterns of interactions, but at the same time, we can see from the closers that it can sometimes hide that really interesting disparity between sort of being pulled towards particular types of interaction and away from others, rather than that kind of average that we would just get looking at MRC. Um, what we have seen is that the types of interactions which I kind of associated sort of informally with high responsibility do seem to be really important. But again, there's more work we can do there looking at potential repository ownership or looking at the ways in which people's access levels correlates with their interactions generally. And what we have to say here is that obviously responsibility and the concept of that and the expectations of interactions that people are going to do as developers or RSEs on a project really varies from project to project. And so that would be really difficult to pull apart from the data. Something really interesting that I had expected to kind of come out of this research, but didn't really seem to result too much in the end was commit classification. So I looked at commit size and the file types, so perhaps commit activities such as build related commits versus documentation related, and message keywords such as fix or add. Um, these were things that I applied from research, but I didn't really see any significant differences from the results as they stood. But perhaps that's something that needs to be involved in the clustering stage to kind of really make a difference. Um, so we've looked at repositories, but we can sometimes forget that repositories aren't always projects. They're not always the same. I've discounted forks within my data set because I think it really it adds an extra layer of complexity, which would have been difficult to unpick. Um, and I was looking particularly at collaborative coding. But some of the literature suggests including all of the forks and working at that project level. So perhaps that's another step forward for this type of research. And anyone who's been involved on larger, kind of more organized projects uh, might recognize the flaw that there's a lot of offline work that won't show up in the GitHub API data. So this might be anything from having meetings about the software, offline code review, through to using external tools such as Trello to kind of manage the development. And those are things that wouldn't be pulled into my data set. Um, we also have the potential for skewing in our data set. So looking at repositories such as ones which have been posted on Zenodo, we might get preference to people who have done a little bit of polishing in their repository before publishing it so that we don't see the true behavior, but we see behavior associated with people potentially publishing their code. Um, there are certainly some things which um, are worth thinking about for future. Bots were not excluded in after my pilot study, but I think that they would be really really interesting to reanalyze now, um, because initially I didn't see a vast amount of difference between the human and bot contributions. So I left them in because it's quite difficult to kind of pull those out. Um, but it's worth seeing whether they fall into the same persona overall or whether bots have different personas or whether they're skewing that data. I think that'd be really interesting. Um, there are some kind of elements where our methodology can definitely be improved. So we might think about adjusting the values that we're using in the clustering, or potentially looking at weighting different interactions for rarity or importance. Um, but at the ultimate kind of thinking about this overall, I'm quite happy with the relative contribution method because it means we can compare people between repositories and within repositories quite nicely without thinking about, well, this repository's been going for 10 years, that one's only been going for 3, therefore we have to scale these differently. So um, it's quite an interesting way of doing it, but it's certainly quite a naive approach, and I think there's probably better ways we can develop this. Uh, a really important takeaway from this research that I would really hope you bear in mind is that quantity and quality are very different, and my work only looks at the quantity. So I can say who has contributed lots or little, but what I can't say is how effective or how important or valuable those contributions are. And this is something that would require much further work to really kind of link up with that. Um, Obviously, as we said before, the people who don't leave footprints in the data are unfortunately missing from this persona description. So that's something that might be worth looking at. And in a similar vein, we don't necessarily know much about the dynamics of how personas interact. So, the kind of mathematicians or numerically gifted amongst you have maybe noticed that using this MRC value or these repository contribution percentages, if you have a very high contribution percentage, like 80, then that only leaves 20% for anyone else, which means that we will never see more than one high interactivity persona in the same repository. They don't play well together, statistically speaking. So really looking at how people become that sort of primary contributor over time or as repositories age and change, does that vary? How does that work? That would be really interesting, and it's definitely something that I'm looking to move on to for the final chapter of my thesis. So in conclusion, RSC personas are a novel method that I've kind of developed within my research over the last few years, and I managed to successfully apply it to nearly 4 million interactions across over 100,000 repo individuals. And that's across over 1,000 repositories on GitHub data. So it's not a bad data set. I'm quite proud of that, and it took quite a long time, given GitHub's rate limits, to get hold of. But now it's available as supporting data for the paper. So if you're interested in that, then there's a link to the preprint, and you can kind of follow the trail there. Um, but I've described these 7 RSC personas and the different patterns of how they contribute in their repositories based on their data. And we've seen that we can kind of describe these relationships between sets of personas based on the high, moderate, and low interactivity groupings. Um, and quite happily for me, some of my originally hypothesized personas do seem to be there and represented in the data. So that's really rewarding. But really, really interesting. There were more that I really hadn't expected or I hadn't quite characterized in my head. And that's where this data driven personas approach really kind of bears fruit because it shows you what's there rather than just what you can imagine. Um, and so we have these ephemeral contributors and moderate contributors, and then these two really interesting closer personas with slightly different behavior profiles. So uh, there's lots of potential next steps, but I think what would be really interesting is to link this research up with other research, such as the research software project categorizations. I know there's been research on that quite recently coming out. Um, and I think that looking at the personas who are involved in research software infrastructure projects versus research software projects for things like data analysis pipelines would be really interesting. Do they have different requirements? Does that attract or create different kinds of personas? Looking at evaluation and doing some mixed methods kind of work, the qualitative to really support this quantitative data by asking people about their perceptions of these personas or if someone has a persona predicted from their data, do they identify with that? Or what could be added to these personas to make them really useful as concepts for research software engineers to think about and use? And again, thinking back to those dynamics, I'm really, really curious to see how that works because I know that it's likely people will have different approaches on different projects. Um, but to what extent will we see that? And will there be any carryover? So yeah, hopefully I can present more about that research, or you might see it coming past in publications in the next year or two. I think really making this accessible by creating a tool which would allow you to plug in a repository name and a username and find the kind of RSC persona that way would be really great, would make it much more easy to use for the RSC community. And I'm currently working on an extended abstract where I'm evaluating some machine learning techniques. So I'm looking at ensemble trees to see whether some of them are better than others for predicting RSE personas from the data. So as I mentioned, this talk is based on the kind of paper that's come out of the poster. So it's a lovely evolution. But if you want to know more, then the link here for the preprint is available. And I'd also once again like to thank everyone who was involved with the DRSE conference because the poster session really, really helped shape my thinking about this. And it also helped kind of reassure me in a way that people do really engage with this idea. So if you have kind of ideas or questions, I will be really, really happy to engage with you about it. That's all from me. Thank you very much.
Thank you for watching our seminar. Please check out the slides on Zenodo linked below and see you next time.